Hello, kids. I think I have a relatively short lesson for you today. It's our second day of completing the square vertex form. We're going to throw in a little bit of review of older stuff as well. So again, this is for the live lesson that'll be on Thursday, April 23rd. As always, lesson will be at 1:30, which follows our optional office hours at 1 o'clock. You should be coming to those office hours if you're really confused and you have questions that you need to have addressed. Remember, in addition to my office hours twice a week, there's also Zoom help opportunities from through the AAC. You can get the information on how to access that by clicking on the document on the top of my Canvas homepage that talks about the AAC help. So here, folks, this is nothing new. This is the same stuff that we did couple days ago here on the front page. You see the g of x notation, function notation. We did that in the fall. Remember, that's the same thing as y. It's just a different way of expressing it. We've talked about that before. Okay. So here, we're going to go ahead and, it says find the vertex by completing the square. So if you remember, I hope you do, we're just going to rewrite this, but we're going to leave a space after the b term, after the 8x. And we are going to cut that b term now in half, which gives us 4. We square it, and we get positive 16. But in order to keep the equation balanced, I have to subtract 16 at the same time. The whole purpose of doing this is we created this perfect square trinomial. This will factor to x plus 4 times x plus 4. Instead of writing it twice, I'm just going to write x plus 4 squared, and then these two things together combine to -8. Remember, the vertex is whatever x value is going to make that come out to 0, which of course is -4. And then you also have that -8 hanging off the back. That's the y coordinate. Remember, the vertex is, if I drew some parabola, the vertex is this peak or the bottom if I drew it like this. And that's an important part to know. We're going to talk a lot more about that later on here. Not today, but down the road. Okay. So this vertex form allows us to quickly find that vertex. You might want to try this next one yourself. If you're not too comfortable, watch me one more time. I'm copying it. I'm leaving a space. I am now going to take this b term, cut it in half. I get 2, square it, but I have to keep it balanced. The purpose of doing that is you always create a perfect square trinomial. That comes out to x plus 2 times x plus 2, but I just write x plus 2 squared. And we have minus 16. There's our vertex. Remember, the -2 is what makes this come out to 0. The -16 is just that number there. And these next two, again, you can probably do these yourself. I will quickly go through it, leaving the space, cutting this in half, keeping it balanced. Got to be careful here. This is actually x minus 3 quantity squared. And then you get plus 2, because 11 minus 9 is positive 2. There is my vertex. And we're almost done with this front side here, aren't we? Leave a little space. Half of this is 1. I square it, I still get 1. So I get a vertex right here. Okay. Now I can't have you forget some other thing. Oh, wait, there's another one here. Forget about that. This one's a little bit different, isn't it? We should probably take a look at this. Don't freak out, though. So, x squared. Now, notice how there's no x term here. And the reason why there's no x term is it must have been 0x, but we wouldn't write 0x. Let me go ahead and write it here right now just so you see it. So there's the beach. I'm going to leave a little space, and there's my plus 4. Now watch what happens here. Half of 0, of course, is 0. I square that, I get 0. There's no need to even write plus 0 over here because adding 0 didn't change anything. You see? This stuff goes away. So my equation actually is still, it's the same thing. That's kind of weird, isn't it? Okay, now here, I'm going to tell you why. So this was standard form. This is vertex form. They actually look exactly the same. Now let me tell you why. It's because this vertex form here, it's really the same thing as this. You see, that looks more like vertex form, doesn't it? But there's no need for us to write x minus 0. We just write x. So that's why vertex form looks exactly the same as standard form in this particular problem. That's because you actually have this x value. This is going to be 0, and that's positive 4 for the vertex. So it does look a little bit strange, okay? But don't freak out about it. It happens sometimes, okay? A little weirdness there. But that's this. So this is like the true vertex form, and the true standard form would have been g of x equals x squared plus 0x plus 4. You see, now that looks like standard form, that looks like vertex form, but we don't write that 0x. That's why we wrote that. We don't write x minus 0. That's why they came out to be the same. So that is a little bit strange. Okay, kids, so find the x-intercepts for the following functions. Remember, x-intercepts is the same thing as solutions. This is what we were doing before we left for remote learning, way back in the middle of March. Okay? X-intercept always occurs when y equals 0. There's a little reminder. And we had 3 different methods. I don't think we're going to use all 3 right here. Maybe I'll add another problem on here in a moment. There was the square root method. There was the factoring zero product property method. And lastly, the last thing we were doing before we left was quadratic formula. And we did a little refresher on quadratic formula last week as well. So when I see this one, remember x-intercepts means y is 0. So I'm going to change that to 0. And I'm looking at this thing. And I'm thinking that this might be easily factorable. Remember, if it is factorable, usually factoring is much quicker than quadratic formula. Okay? Let me give this a moment to come back. And, this leading coefficient is 1. That helps with factoring. Now, there's a lot of options here, but I can already see which one I'm going to use. If I use 8 and 3, 8x and 3x can make 5x. Signs are different. Bigger one's positive. And that's my factoring. Now remember, we're not done with that. We actually have to write down the solutions. What makes this come out to 0? How about here? Those are our actual solutions. All right. Okay, remember, change, that's x-intercepts means y is 0. And when I look at this thing here, the first thing when we do factoring, folks, I didn't mention it over here, but because there wasn't one. But is there a GCF? I hope you remember that. There is a GCF here. That GCF is going to be 4x. It actually makes this problem super easy, right? So now all you have to do is ask yourself, what's going to make this parentheses come out to 0? And that's, of course, -3. What's going to make this come out to 0? X would have to be 0, because 4 times 0 is 0. So don't forget about that GCF possibility, okay? Sometimes you do a GCF and then do something like this. Now, number 8's different as well, okay? Number 8, if you guys notice, it does not have a b term. There's no x term. And when you don't have the x term and you just have x squared and the constant, you can solve this using the square root method. So you want to get x squared by itself. So we move the 8 over by adding it. We get rid of the 1/4 by multiplying both sides by 4. So we get 32 equals x squared. Now we're going to pull on some of your skills that we just did in the last unit. Remember, we have to take the square root of both sides now to get our answer. Okay? And so x equals the square root of 32, but we can simplify that. Biggest perfect square that goes into that is 16. Goes into that twice. That comes out as, so we actually get an answer of 4 root 2. Now you could have done a calculator and gotten a decimal, but now you got to be careful here. One thing I forgot to do, remember, it's really plus or minus. So 4 root 2 times 4 root 2 would give you 32. But negative 4 root 2 times negative 4 root 2 would also give you 32. So don't forget, remember those plus or minus ones. Now here, I'm gonna, if you realize, folks, if you try to factor this, the only factor pair of 3 is 3 and 1. The only factor pair of 1 is 1 and 1. This gives me 1x and that gives me 3x. Well, if I add or subtract those, 3x and 1x, there is no way I'm going to end up with 1x. This does not factor, okay? Does not factor. And if something doesn't factor, it doesn't mean it's no solution, okay? It means that you have to use quadratic formula. So that's where I write down our A, B, C, 3, 1, -1. X equals opposite B plus or minus square root B squared minus 4 times A times C all over 2 times A. And if I do what's in the square root here, 1 squared, I get negative times a negative is positive. I actually get 1 plus 12, which is 13. So that's not a perfect square. You know, this thing was not factorable. So now I have to do -1. Remember, I have to do -1 plus square root of 13 over 6. I'm going to do that right now on my calculator. And I got 0.43. That's one of my answers. And now I just have to do it again, but now I have to do the minus. And I'm going to do that here as well. And I got -0.77 if I round. I'm going to do that again just to make sure I did it correctly. Looks good. So you see, we have these three methods of solving these quadratics, and we were talking about all three of these before break. So we're kind of I'm kind of spiraling back here a little bit. Did a little quadratic formula here with this last problem, and we did some of that last week when we did the discriminant. We did some factoring. We've seen some of that, a long time ago, a lot of it, and then again here recently. And we have that square root method. When you don't have a b term, you go ahead and isolate the x squared. Okay, so you're going to see some of this in your homework, and we'll call it a day. Remember, the live lesson is on Thursday at 1:30, April 23rd.